Ever wonder why a massive skyscraper stands firm, but a small retaining wall can fail overnight? It almost always comes down to one hidden, unpredictable factor: the sheer strength of the soil beneath it. Guessing isn't an option in geotechnical engineering. Today we are taking the guesswork entirely out of the equation. We're going to walk through exactly how to measure soil shear strength using a complete triaxial test setup. Welcome back to Certified MTP, your trusted source for material testing equipment. If you are designing foundations, dams, or evaluating slope stability, you need to know exactly how your soil behaves under pressure. The triaxial test is the gold standard for doing exactly that. Unlike a simple, unconfined compression test, a triaxial test replicates the exact pressures a soil sample experiences deep underground. To accomplish this, you need a precise system. Today, we are looking at three essential components. Number 1, the triaxial and permeability master control panel. Number 2, the analog triaxial component set, featuring the triaxial cell and the 1,000-pound force load ring. And number 3, the soil testing load frame, specifically our Pro Loader. By the end of this video, you will have a simple, complete understanding of how to operate these three products together to perform a standard triaxial shear test. Let's break down the process step by step, starting with how we simulate underground pressure. To test soil properly, we first have to recreate the environment it came from. When soil is buried 10, 20, or 50 feet below the surface, it is being squeezed from all sides by the dirt and water around it. We call this confining pressure. This is where our first piece of equipment comes in, the triaxial master control panel. This panel is the central nervous system of your test. It regulates the flow of air and water to apply precise pressure to your soil sample. Here is how you use it. The panel connects to an air compressor in your lab. When you look at the front of the panel, you will see clear burettes for water, precision regulator knobs, and high-accuracy SI pressure readouts. First, you fill the burettes with de-aired water. De-aired water is critical because any trapped air bubbles will compress during the test and give you false readings. Next, you use the precision regulators to set your target pressure. As you turn the dial, keep your eyes on the PSI readout. The analog gauge provides a continuous, real-time display of the pressure you are dialing in. If your engineering specs require a confining pressure of 15 pounds per square inch to simulate the depth of a foundation, you simply adjust the regulator until the needle rests perfectly on 15. The panel holds this pressure steady, feeding it directly into the triaxial cell where your soil sample is housed. It's a simple, reliable system designed to remove fluctuations so you can trust your data. Now that our control panel is ready to deliver pressure, we need a place to put our soil. That brings us to our second product, the analog triaxial component set. This set includes the triaxial cell itself, the porous stones, the latex membranes, and our 1,000-pound force load ring. Setting up the triaxial cell requires care, but the process is highly straightforward once you know the steps. Step 1, prepare your soil sample. It must be a perfectly trimmed cylinder. Step 2, place a porous stone at the base of the cell pedestal, followed by your soil sample, and then another porous stone on top. These stones allow water to flow in and out of the sample without letting the actual dirt escape. Step 3, the isolation phase. You cannot let the water in the chamber touch the soil directly. Using a membrane expander, you carefully slide a thin rubber latex membrane over the soil cylinder. You then secure the top and bottom with thick O-rings. Your sample is now completely sealed and waterproof. Step 4, assemble the chamber. Place the heavy-duty clear acrylic cylinder over the sample and bolt down the top cap. You then connect the tubes from your master control panel to the base of this cell. Once connected, you open the valves on the panel. Water rushes into the acrylic chamber, surrounding the rubber-wrapped soil sample. As the pressure builds to the PSI you set earlier, the water physically squeezes the sample from 360 degrees. You have now successfully recreated the underground environment. But to measure strength, we have to break the soil. For that, we use the 1,000-pound force load ring included in the set. The load ring sits on top of the triaxial cell. As force is applied to the sample, this steel ring actually bends on a microscopic level. The analog dial inside the ring measures that bend, telling us exactly how many pounds of force are being applied at any given second. We have our pressure, we have our sample. Now we apply the load. This is the moment of truth, and it requires our third piece of equipment, the soil testing load frame, specifically our Pro Loader model. The Pro Loader is an absolute powerhouse. It is designed to push upward with immense, unwavering force at a highly controlled speed. In shear testing, speed is everything. If you crush the soil too fast, water gets trapped inside the soil pores, throwing off your strength calculations. You have to shear the soil slowly. Here is how you operate the Pro Loader. First, place your assembled, pressurized triaxial cell onto the lower platen of the frame. Next, lower the crosshead of the machine until the piston of the triaxial cell makes gentle contact with the 1,000-pound force load ring. You want them touching, but you don't want to apply any real force yet. Once they are seated together, zero out the dial on your load ring. Now look at the front of the Pro Loader. You will see controls to set the strain rate. This is the speed at which the lower platen moves upward. For most standard consolidated undrained or unconsolidated undrained tests, this speed is incredibly slow, sometimes moving just fractions of an inch per minute. Set your required speed and hit start. The heavy-duty stepper motor engages. The bottom platen begins to rise. As it pushes the triaxial cell upward, the sample is forced into the rigid piston. The soil is now being sheared. During this phase, your job is to observe and collect data. You will watch the dial on the 1,000-pound force load ring. As the frame pushes harder, the needle on the dial climbs. You or your automated data logger will record the load ring reading at specific intervals of deformation. Eventually, the soil inside the chamber will reach its breaking point. It will bulge, or a visible shear plane, a diagonal crack, will form across the cylinder. The needle on your load ring dial will hit a peak and then start to drop backward. That peak number is your maximum load. The test is complete. You hit stop on the Pro Loader. You release the pressure from the master control panel, drain the water, and remove the cell. By utilizing these three specific products in harmony, you have successfully isolated every variable. The master control panel gave you exact, verifiable underground confining pressure. The analog component set securely housed the sample and allowed the 1,000-pound force load ring to capture minute changes in force. And the Pro Loader load frame delivered a flawless, continuous rate of strain to ensure your data wasn't compromised by mechanical stuttering. When you take the peak force recorded on your load ring and combine it with the confining pressure from your panel, you can plot your Moore's circles. This gives engineers the exact cohesion and internal friction angle of the soil. With those two numbers, they can safely design building foundations, retaining walls, and embankments that will stand the test of time. It is complex science, made incredibly simple and repeatable with the right equipment. If your geotechnical lab is ready to upgrade its testing capabilities, or if you are setting up a triaxial testing station from scratch, you need equipment that guarantees accuracy on every single test. We carry the Triaxial Master Control Panel, the analog component sets, the Pro Loader load frames, and all the accessories you need to run flawless shear tests. Head over to Certified MTP at the link in the description below to browse our full catalog of soil testing equipment. If you found this walkthrough helpful, hit that like button and be sure to subscribe to the Certified MTP YouTube channel for more deep dives into material testing equipment. Thanks for watching, and we will see you in the next video.